Alright guys, if you started this, you couldn't get all the way through it because I didn't give you numbers on the last two, but hopefully you try to set up this one. A bunch like this on the homework, and the question I would ask in class is which one do you have to get first, X or Y? You know, if you knew one of these, you could realize maybe they're linear pairs and you can just subtract the other one from 180, but you don't know one of them yet, and you're sort of forced to solve for X first. And you'll notice that X appears in two different locations on here. One is over here as an exterior angle, and the other one is really far away, this remote interior. And I happen to give you this other remote interior, with no way to find that top one right now. So hopefully you recognize that these two are remote interiors to that exterior angle, which is the theorem that was just covered, 2 seconds ago on this thing. This angle is equal to the sum of these two. It's just an application of that theorem again. This angle is equal to the sum of these two. So your equation, maybe obvious to some of you, is 4x minus 140 equals 40 plus x. Pretty easy equation to solve. Add 140 to both sides, subtract x, and you get 60. After division at the end, divide 180 by 3. And then of course if you have x, y is very easy to get. This is 60. Y must be 120 because they're linear pairs. So pretty simple setup on that one. The second question, a couple numbers just came up. 50 came up on here, and the 70 came up on here. And I want you to solve for x, y, and z. And also the blue arrows are on here. The blue arrows are important. Little review from chapter 3 built in here. Blue arrows meaning there's parallel lines. And I would argue that the variable you want to solve for first is y. I would say solve for y first because it's kind of given. This is a good time to pause and try to get all three of them. If you want to just listen and copy things down, you could without doing any thinking, but I would recommend you pause it, try to think for about a minute or two, see if you can get x, y, and z, and then check your answers here in a minute. I also included justifications. It says to justify with a reason, a geometric reason for each of these, or a theorem. I'm hoping you get y first because you recognize the little z on here. Y is 50, should be congruent to this one because they're alternate interior angles. So hopefully you jumped right to that first. Oops. So that's sort of a given on there. The other thing I'm hoping you recognize that x is pretty easy to get. If you just look at this triangle and ignore everything else, if that's 90, then these two have to be complements of each other. In other words, these have to add up to 180. Subtract that 90 from the 180, you get this one plus this one equals 90, which means x has to be 40. So x and y are pretty simple to get those in the beginning. I would be patient, not worry about finding z till the end. These, of course, have to add up to 180, so you could just do 50 plus 70 plus z equals 180. They should have ended up with z being 60. Now, I'm not showing all the work that you're going to show on your paper, but these are the answers on there. Certainly, you're going to set up equations and solve them like you would on any homework assignment or any other assignment. This is a tricky one. This last one's a tricky one. I just shot up a few more things on there. The angle on the left is 50. The angle on the right is 50. Top angle on the right is 64. You're trying to find z, which is out here, and you're trying to find the value of x. Again, it's a good time to pause and try it on your own. This took us probably 5-10 minutes to talk about in fourth period today. So this is one I'd take your time, think it through. A big thing to think about is which corollary applies. Hoping you see the yellow triangle and the white triangle overlapping each other, and they have two congruent angles. The two bottom angles for the yellow triangle are the same as the two bottom angles for the white triangle. So if these are congruent and these are congruent, then the x squared, the 64 and the x squared should be the same. And it's a quadratic, which means you're going to get two answers for x. X could be 8, x could be -8, and you're using that third angle corollary to set that up. Two angles of a triangle are congruent to two angles of another triangle. The third angles have to be congruent to each other. Z is much trickier to find. I would highly recommend you pause, you think through this, and say, how the heck do I get Z? Because it takes multiple steps on here, which I'm not going to show up here. But you certainly should work through them and show them on your own paper somewhere on there. But I'm going to talk through them. You'll definitely, to get Z, You'll notice some people in the other class noticed Z was vertical to this angle in here. So if you could find this angle, you could get Z, and you'd have Z on there. If you look at this little triangle is an isosceles triangle. It's got two congruent angles, which means it also has two congruent sides. So if you could find these angles, you could add them together, subtract from 180, you'd have that one. So go back to maybe the white triangle. If this is 64 and this is 50, add those together and subtract to find that angle. And whatever you get for that one, you get the same thing for this one. I believe this ends up being 66 degrees, and this ends up being 66. Check my math on that. And then you do 66 plus 66, subtract 180 to get this one, and then it's a vertical angle to the one above it. I think Z should be 48 at the end of the day on that one. So those are, it's a tricky problem, that last one, in terms of how to get logically through it. The next one on your paper, you're going to have to extend this line here and mark these two angles. And as you look at that, I'm hoping you realize that if it has two congruent angles, this is an isosceles triangle. In other words, if these angles are congruent, then the sides over here, these lengths have to be the same. Not that it matters because we're working with angles on this one, but it does relate to the next section we're going to talk about. And these are the only things I'm going to give you. 5x plus 24 is equal to, sorry, not equal to, 5x plus 24 is one of these angles. 2x squared is that exterior angle that you just created by extending a side on there. I would usually wait 2 minutes probably in class to let you try to set up equations on this. So I would hit pause, work on it for a minute. If you come up with an equation you think you can solve it, go for it. If you can't, come back, tune back in here and look for the solution. Start some steps to the solution, sorry. So just to talk about a couple of mistakes I saw. I saw one person in the other class called this x and said, well, x is equal to 5x plus 24. Well, this is not actually x. This is actually 5x plus 24 because these are supposed to be equal. Saw somebody in the class also say, well, 5x plus 24 equals 2x squared, saying these angles are equal. They're definitely not equal. However, this exterior angle is equal to this one plus that one. So there's hopefully your equation. The sum of these two is equal to that exterior angle. There's the exterior angle theorem, again, useful in this problem. You combine like terms, you get to there. You can try to move these things over right now if you want. Subtract that and subtract that. And I'm hoping you can solve from here. Now, if you try to factor that or use quadratic formula, it's a bit messy from this step. I would recommend maybe dividing by 2, dividing by 2, dividing by 2, and try to solve it. Before you move on to the next question, read this and think about what I'm asking for. It's not on your paper, but it's up here. Use the drawing scale to evaluate your answers. You're going to get 2 answers here, but only one of them makes sense. I'm going to pause now and go to the last part on here, so I'll be back in a minute. Good luck. See if you can finish that up and get the values of x. I'll be back in a moment.